Imagine your employees having instant access to every piece of knowledge they need to do their jobs. No more endless searches, no more guesswork. I am the AI agent guy, and today I'm going to show you how to empower your business with an AI copilot that knows your business inside and out. Let's talk impact first. Companies implementing AI copilots with comprehensive business knowledge are seeing an average 40% boost of productivity according to this MIT article, and a 25% increase in employee satisfaction. I've personally guided over 75 organizations in the past 12 months in adopting this technology, which reduced decision-making time by 60% in just 2 months. These AI-powered assistants aren't just luxury. They are becoming essential for staying competitive. What's most shocking to me is that most SMBs owners don't even know how they are missing out in the race of AI implementation. In the next 15 minutes, you'll discover an AI chatbot with access to a knowledge base that is self-reflecting on its answers rather than giving you a simple and imperfect answer. By the end of this video, you should be closer to understanding how to benefit your business with AI. But first, let me give you an explanation to understand the concept better before I demonstrate you the actual code you can immediately implement into your business after this video. So first things first, what's a RAG? As you can see in this slide, is a special database called vector database that is added to a chat application like ChatGPT. This is helpful in the sense that you can give the AI access to whatever knowledge base you want, like every detail of your business knowledge or know-how, from financial reports to customer histories, product specs to marketing strategies, and so on. One of the biggest challenges for any business is ensuring that every employee has access to the right information at the right time. But instead of scattered knowledge bases, slow down decision-making and hinder collaboration. By implementing a central knowledge base that houses all your critical business information, from processes to procedures to best practices and FAQs. Ensure it's organized and easily accessible through an AI copilot. And the result is a well-structured knowledge base. Your AI copilot can quickly retrieve the exact information your employees need, boosting the efficiency and confidence in decision making. Did you know employees spend an average of 1.83 hours every day searching for and gathering information? AI copilots can cut this time by up to 90%. Now let me explain to you how a basic Retrieval-Augmented Generation or RAG system works by breaking down the process step by step. Step 1. The question. The process begins with a question or query, like when you would chat with ChatGPT, but to get answers from your knowledge base. This question is essentially what the system will use to find the best possible answer. Think of it as a starting point where the system kicks into action. Step 2. Indexing. In the next step, the system uses an index, a special vector database optimized for quick searching. But before this can happen, all the documents need to be indexed. This involves processing and organizing the information in a way that makes it easy to search through later. These documents could be anything from PDFs to entire databases, and they are processed to be ready for a quick retrieval. Step 3. The retrieval. Once the question is passed through the index, the system retrieves the most relevant documents or pieces of information. These documents are selected based on how closely they match the query. The goal here is to gather the most useful bits of information that could potentially answer the question. Step 4. The generation. Now this is where the magic happens. The retrieved documents are passed into a large language model, like ChatGPT. It's a segment of text that the model uses to understand the content. Then the model processes the context and generates an answer. Essentially, it formulates a response based on both the query and the relevant information it retrieved earlier. And step 5, the answer. Finally, the system delivers the answer to the user. This response is generated in a natural language, making it easier to understand and directly related to the original question. However, the reality is far more complex. This basic version, despite its widespread implementation, often falls short in real-world applications. Its primary flaw, a tendency to hallucination and retrieving inaccurate data from the knowledge base. In a business environment where employees and CEOs rely on precision, such inaccuracies are simply unacceptable. And here comes a game changer. Self-reflecting and self-correcting RAG. This advanced system goes beyond the basic, employing a sophisticated mechanism to scrutinize its own outputs. By doing so, it it achieves a level of reliability crucial for real-world deployments, unlike the simplified RAG systems, often showcased in YouTube tutorials, which serves more as a proof of concept demonstration. Self-reflecting RAG is engineered for demands of actual business environments. It's not just about functionality, it's about trustworthiness and peace of mind for businesses that depend on accurate, reliable information retrieval. Now let's explore this advanced RAG system. As you can see, this version includes additional steps to improve the accuracy and relevance of the answers. Here's how it works. Step 1. The question. Just like the basic system, the process starts with a question. The question is what the entire system is built to respond to. Step 2. The retrieval node. The first active step is the retrieval of documents. The system searches through a vast set of indexed documents and selects those that appear most relevant to the question. This retrieval process is similar to what we saw in the basic RAG system. In step 3, the grading node, here's where things get more sophisticated. After retrieving the documents, the system grades them. This grading process assesses how relevant and useful the retrieved documents are in answering the question. Step 4, document relevance check. At this point, the system asks itself, are these documents relevant enough? If the answer is yes, it moves on to the next step. If not, the system doesn't just give up. It rewrites this question. This rewritten question is designed to improve retrieval, and the process starts over with this new question. In step 5, generation node. Once relevant documents are confirmed, the system generates an answer. This step involves using a language model which creates a response based on the information extracted from the retrieved documents. In step 6, the hallucination check. A critical enhancement in this advanced system is the check for hallucinations. Hallucinations are instances where the model generates information that is not supported by the retrieved documents. If hallucinations are detected, the system loops back to the retrieval or grading stages to ensure the information is accurate. If no hallucinations are found, the system proceeds. And step 7, the answer validation. Finally, the system evaluates whether the generated answer truly addresses the original question. If it does, the process ends and the answer is provided to the user. If not, the system may loop back and either generate a new response or refine its previous steps to improve the answer. And last but not least, the answer. Assuming the answer passes all these checks, the final answer is delivered to the user. This multi-layered process ensures response is both accurate and relevant, minimizing errors and improving the quality of the information provided. Assuming the answer passes all these checks, the final answer is delivered to the user. This multi-layered process ensures that the process is both accurate and relevant, minimizing errors and improving the quality of the information provided. Now let's dive into the actual code. I used LangGraph to design the workflow for the self-reflecting RAG chatbot. My inspiration came from the example provided by the LangGraph team on their GitHub repository, which is based on a paper that delves into the theory behind self-reflecting RAG. Building on their example, I made several improvements to adapt it for a real-world application tailored to my client's needs. Today I'll be walking you through those enhancements in detail rather than covering the entire code. I also include the relevant link in the description below for further reference. Now, let me scroll down to the vector store function. In the original example, ChromaDB was used, but I decided to switch to Milvus. While ChromaDB is a capable vector database, it's not yet mature enough for production use in my opinion, for a number of reasons. Milvus, on the other hand, is a more sophisticated vector database. It's fast, efficient, and most importantly, scalable. This makes it an ideal choice for real-world applications that need to handle large volumes of data effectively. For the knowledge base data, I used this PDF file, Text Guide 2023 from Ernst & Young. So, here we are defining the load or create vector store function that will either load an existing vector store or create a new one if it doesn't exist. In this function, we're connecting to a Milvus. Here we are trying to connect to our Milvus collection. We are using OpenAI's embedding function to convert text into format our AI can understand, specifying the collection name and providing the connection details. Next, we're checking if the collection exists or is empty. This line is crucial. We are checking if our knowledge base is empty or doesn't exist at all. If either of these is true, we need to start creating a vector store. The purpose is to not embed our PDF files every single time we start chatting with the AI, to save API costs and time. Next, load and process documents. If our library is empty, we kick into action. This is just us saying, alright, time to build this database from scratch. Here we are loading all our PDF documents and making them ready to be processed. Now we are breaking down our documents into smaller, manageable chunks. This helps our AI process and retrieve information more efficiently. Think of it as creating detailed index cards for every few paragraphs in our PDF. Next, we creating the vector store. This is where the magic happens. We are taking all those document chunks and storing them in our Milvus vector database. We are using OpenAI's embedding function to convert the text into a format that's super efficient for AI to understand and search. If the collection already exists and has data in it, we simply let ourselves know we are good to go. And returning the vector store. Whether we created a new knowledge base or found an existing one, we return it so it can be used, and putting it all together. Now outside our function we use it. Vector store equals load or create vector store. This line calls our function either loading or creating our vector store. Finally, we create a retriever from our vector store. This is like giving our AI a library card. Now it can quickly find and use any information it needs. Now let me quickly walk you through the core concept of LangGraph. What sets LangGraph apart from other frameworks like CrewAI or AutoGen is that it operates at a relatively lower level, giving you a more control and flexibility. LangGraph isn't as opinionated, which means it doesn't force you into a specific way of structuring your AI. Instead, it functions more like a workflow management framework, allowing you to freely define the functions and behavior of your AI system. In LangGraph, your functions act as nodes. These nodes represent various tasks such as retrieving data or grading documents. Then we have edges, which are the connections between those nodes, determining the flow of information or actions. Additionally, you can use conditional edges to route these connections based on specific conditions or the outcomes of previous nodes. Let's take a look at how this works in practice. As you can see, we start by building a graph by adding nodes, such as the retriever function, the grader node, the grade document function, and others. Next, we add the edges to connect these nodes and define the direction of the workflow. For instance, the workflow starts at retrieve, then flows to grade documents. We can also add conditional edges, which act as routing mechanism based on certain conditions. For example, if decide to generate function returns transform query, the workflow moves to the transform query node. If it returns generate, it shifts to the generate node. And finally, we compile a graph bringing all the components together into a coherent workflow. And down here I've implemented the chat functionality, which I'm excited to demonstrate in the next step. So let's kick off the chat by running the command python main.py. As you can see, the PDF file has already been embedded, so it prints the message using existing embeddings. Now let's ask a question. What is the withholding tax rate in the UK? Watch as it processes the query, running through the checkpoints, grading documents, checking for hallucinations, and finally generate the validated answer. And there it is. An accurate, well-researched response drawn directly from our knowledge base and vetted through a multi-step validation process. Let's try another one. Give me a summary of the CFC rules of the UK. Again, it provides a nicely formatted output rooted in reliable data from the knowledge base. That's all for today, folks. I hope you enjoyed this demo. If you did, please subscribe and hit the like button. Until next time, AI Agent out.